Okay, this video is going to go over transfer functions. So a transfer function is a Laplace transform of the output over the input. Let's start with an example. And let's say we have a state space model for a mass damper system. X1 is going to be our velocity. So x1 dot is equal to negative c over m times x1 plus 1 over m times u1, where u1 is going to be our input, which is a force in this case. And then we have our initial condition for x1, which is going to be 0. And then we have an output y1, which is x1. So we're trying to measure or pay attention to what our velocity is. So let's take the Laplace transform of this equation here. So x1, its Laplace transform will be x of 1 minus its initial condition, which we know is 0. For the second term, it's negative c over m times x1. That's the same thing as negative c over m times x1 of s for the Laplace transform. And again, for this case, all we do is replace little u with big U here. Now, for our output equation, we have y1 is equal to x1, or the Laplace transform of it would be capital Y1 is equal to capital X1. So let's solve this first equation for x1 of s. So we can get that if we were to take this equation right here, move x1 over, we can actually get s plus c over m times x1 of s is equal to 1 over m times u of s. Or in other words, we can say x1 of s is 1 over m plus plus c over m. 1 over m divided by s plus c over m times u of s. Let's plug that into our second equation. So essentially x1 and y1 are the same exact thing. So we got y1 is equal to the same exact thing. And now we're going to divide by u1 of s. So y over u, which is our transfer function tf of s, is 1 over m divided by s plus c over m. And that's what a transfer function is. It is your output over your input for any Laplace transform. And that's the basics for a transfer function.